So page 18, number 6, if a population grows at a constant rate of 2.8% per year, then by what percent will it grow over the next 10 years? So again, they don't really care about the amount or the starting amount. We're just looking at this part. So it's growing at 1.028 or 1 plus 0.028. And I'm going to use y again for years. Now they want to know what percent will it grow over the next 10 years. So you might be able to just figure this out in your head. Or let's do our little conversion. 1 year to 10 years. This goes from a smaller measure to a bigger measure. So our exponent is going to be a whole number, not a fraction. So I'm going to say A equals P 1.028. And then I'm going to put a 10 here. And my new, I'll just keep it like 1. Because it's still years, it just happens to be 10 of them. And what I end up in here is 1.318. Now, to find your rate, you take your base minus 1. So in this case, it's 1.318 minus 1. So it is about 32%. Number 7, this is a half-life problem now. And to save some time on the video, I just put the correct formula to use. The half-life of a radioactive material is the amount of time it takes for 50% of its radioactivity to decrease. Okay, great. That's just the definition of it. It's not even the problem. If a particular material has a half-life of 35 years, that's H, what percent will remain radioactive after 100 years? That's our time. So we're just going to plug in what we have. 1/2. Let's see, 100 T over H, 35. Now I'm going to simplify everything I can. If I do 1/2 raised to the exponent of 100 over 35, I'm going to get 0.138. This is how much actually remains. So if you turn that into a percent, you move the decimal place 2 spots right, and you get 0.1 or 13.8%. Number 8 now. This is getting into different types of compounded. It says if $500 is placed in a savings account that earns 6% interest compounded monthly, which of the following represents the account's worth after 10 years? So we have our initial value, P. Our rate is 0.06. And I highlighted that because of the word compounding. If you have a regular rate, you assume it's yearly, and it's compounded monthly, then you have to use this formula for periodic compounding. And then time is 10. So I'm going to plug in everything. 500 is our P, 1 plus R over N. I didn't write that one down yet. So yearly interest compounded monthly, that means our N is 12. So that goes there. And then it's raised to the N, and T is 10. You put all of that carefully in your calculator, and I got 909.70. So right here, about $910. Number 9, we're going to get into solving equations with these now. How many years to the nearest tenth would it take for an investment to double? This is not the doubling formula. They just want to know when the money you got doubles. If it is earning a continuous compound interest, so because it's continuous compounding, you use the PERT formula, A equals P times E to the R2. So our rate is 0.035. Now let's just pretend, because I like to pretend, we have an investment of $1. So I'm just going to assume our P is 1. That means our A value, since it doubles, is 2. You can use any starting number you want and you'll get the same answer. So I'm going to put a 2 in for A, a 1 in for P, e to the 0.03. And we don't know t. They want to know how many years. So we're going to solve this. First, I'm going to get rid of that one because it's bothering me. E to the 0.035 t. This is actually in base exponent number form. So I can use a logarithm. Log base number equals exponent. And then to get the t by itself, I divide by 0.035 on both sides. Remember, log base c is the same thing as ln, so you could use the ln button as well. When I put this whole thing in my calculator, I end up with t equals 19.8. And remember, to get the log button on a graphing calculator, you choose alpha window number 5. Last one on this page. The profits for a large microchip company have increased, blocking my stuff out, 7.75% annually for the past several years. Okay, well, we know our rate is 0.0775. And we know it's yearly. Which of the following expressions represents this growth in terms of quarterly percent increase? There is no word compounding in there, so you use your simple interest formula. So Q represents the number of quarters. So in this problem, again, they don't really care about the A and the P. You can put that in if it helps. We know our interest is 7.75, so 1.0775. And I'm going to use a Y again for years. Now, if I'm going to go from yearly to quarterly, I go from a larger unit of measure to a smaller, so I do a fraction, 1/4. So to rewrite this now, 1.0075, the 1/4 goes here, and this Y turns into a Q. And then when I simplify this piece, when I raise 1.0775 to the 1/4, I get 1.0188 Q. So that is number 4. These are very tricky. Don't get down on yourself. Just keep trying them out. They're very, very tricky. Go ahead. Try the next page. 11. Give number 12 a try. Number 13. And then go back and watch the video and see how you did.